All right, you guys, so we're picking back up with our radicals since we're going to need those for 5-7 and 5-8, and then we'll need them again in Chapter 8. So here is some more simplifying radicals. If you need some more practice on those from what we did last Friday, you can go back and rework any of those you want to. I wanted to tell you how you could check your simplifying radicals on a calculator if you wanted to just make sure you got it right, would be to plug them in both ways. Here and like this, and change them to a decimal and see if they match. So when I put square root of 24 in the calculator, I get the decimal 4.8989, blah, 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 blah. When I put 2 on the square root of 6 in the calculator, I get 4.89, blah, 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 blah. So since the decimals match for both of these, then I know I simplified it correctly. So you can't use your calculator to simplify radicals, but you can use it to check and make sure that you did it appropriately. Okay, so for adding and subtracting, sorry, I got that thing in there. I don't know how to get it out. All right, so for adding and subtracting radicals, if you will think about it just like you think of variables, it'll be very easy. If they have a like term under the radical, you can add them. If the radicands don't match, you don't add them. You leave them alone. So just like if you were to say like, hey, what is 2x plus 3x? Well, I have 2 of these and 3 of these, so altogether I have 5 of those things, right? All you did was you added the coefficients and you left the variable the same. So adding and subtracting square roots is exactly the same. So I have 2 square roots of 3 plus 3 square roots of 3. Okay, so these are like terms because they're both square roots of 3. So I just add the coefficients. 2 of these plus 3 of these. Oh, look, there are 5 of those. I don't touch the radicand at all. I don't mess with it. Just like you didn't mess with the x. It's the exact same process. Same way if you had like 2x plus 3y, you would say, hey, these aren't like terms, so I can't add them together. I don't do anything with them. I just leave them alone. It's the exact same thing for radicals. If they're the same, you just mess with the coefficients. If they're different, you don't mess with anything at all. So here, my radicands are the same, so I just do whatever they say to do to the coefficients. 6 minus 2 is 4. 4 on the square root of 3. Okay, here, square root of 3 and square root of 2 are different, so I don't do anything with those. I just rewrite it exactly the way it is. I just leave it alone. Okay, you try the last two and see if we match up. Okay, so here's the answer to these two. Square root of 5's both match, so I just add the coefficients. 5 plus 1 is 6 on the square root of 5. For number 4, I have 2 like terms. 6 square roots of 2 minus 4 square roots of 2 is 2 square root of 2. And this square root of 3 doesn't have any like terms, so I just bring him down. Okay, multiplying radicals, you have 2 different choices for how you can do this. You really need to understand both ways because the problem could be set up where you have to use choice 2, but for most problems you can choose whichever way. So choice 1, I have a same example here done both ways. So I'm multiplying square root of 12 times square root of 8. So choice 1 just says multiply what's under the radicand. They don't have to be like terms because I'm not adding, I'm multiplying. Just like if I said x times y, I can do that. X times y is xy. So they don't have to be like terms to multiply. So 12 times 8 is 96. And then I just break down 96. So I zoomed in here. 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. A 2 comes out here, a 2 comes out here. So I have 4. 2 and 3 are the lonely losers. Okay, so for choice 2, I'm going to break them down before I multiply. So 2 and 6, 2 and 3. So 12 is 2 on the square root of 3. 8 is 2 and 4. Notice that perfect square there. So 8 is 2 on the square root of 2. Now, when you multiply like this, you need to remember outside with outside, inside with inside. So 2 times 2 are the 2 coefficients. 2 times 2 is 4. And then inside with inside, square root of 3 times square root of 2 is square root of 6. So either way I do this, I end up with 4 on the square root of 6. It's really just personal preference and even depending on the problem. Okay, so let's do some together. So 4 and 6 are both pretty small numbers, so this one could go either way. You could probably just say, hey, square root of 4, that is 2. So I can jump out that perfect square immediately. 6, 2, and 3. So nothing happens there. There's no pairs or anything. So I'm just going to leave that square root of 6. So now all I have is 2 on the square root of 6. Okay, you would get the same thing if you multiplied them, square root of 24, and you broke down 24, you would get 2 on the square root of 6. It wouldn't matter which way you did it. Okay, so for this one, 3 and 18. So I'm going to do it the other way just for variety. So 3 times 18, oopsies, is the square root of 54. And then I'm going to, I hate this thing. And then I'm going to break down 54. So 54 would be 2 and 27, 3 and 9. Notice the perfect square there with 9. So 3 and 3. So I have a pair of 3s, so a 3 comes outside. 2 and 3 are the lonely losers, so 6 stays inside. Okay, y'all try number 3 and 4, and then we'll come back together and see how it went. Okay, so here's my results for 3 and 4. 2 times the square root of 5 times 2 times the square root of 2 is 4 on the square root of 10. And then this one worked out pretty because 12 times 3 is 36, and 36 is a perfect square, so it worked out beautifully. Okay, so for dividing radicals, there's either an easy kind or a hard kind. So you're not allowed to leave a radical in the denominator. It's just very much against the rules. It's like you're not allowed to leave a fraction like 2/4. You have to simplify it to 1/2. It's the same thing. So the easy kind is if the denominator is a perfect square. So like this example here, square root of 2 doesn't simplify, it just stays square root of 2, square root of 9 is 3. So now I no longer have a radical in the denominator, square root of 2 over 3 is fine. The radical can be in the numerator, it just can't be in the denominator. Same thing here, square root of 25 is 5, square root of 36 is 6, so that whole thing simplified to 5 over 6. Okay, for this one, square root of 8 is not a perfect square, so you'd have to break that down, do the tree. 2 and 4, 2 and 2. So that's why I got 2 on the square root of 2. And then square root of 25 is just 5. So those are nice and easy when the denominator is a perfect square. Also, I wanted you to just look at this same thing could be written like that where the whole fraction's under there. These mean the same thing. So if you see it written this way, then just go ahead and separate and give everyone their own house and then simplify like normal. Okay, the trickier part is when the denominator is not a perfect square. You have to do what we call rationalizing. So you basically have to get the square root out. And the easiest way to get the square root out is to multiply the denominator by itself. Because think about what that would do. Like if I have the square root of 2, how do I undo that? Well, if I multiply it by itself, square root of 2 times square root of 2 is the square root of 4, which is just 2, and that will always happen. So when you multiply a radical by itself, you just get the radicand, just the number inside. So that's the quickest way to remove a radical in the denominator. Okay, so let's look, but if you multiply the denominator by a number, you have to do the numerator, the same, so that it doesn't throw off the balance. Ignore where I'm talking about 8 power 5. Y'all are lucky ducks. You don't have to do 8 powers. Okay, so for this example here, square root of 9 over the square root of 2. So square root of 9 simplifies nice and easy to 3, and the square root of 2 is not going to do any simplifying. You always want to simplify first so you have the smallest thing possible. So to get rid of the square root of 2, I multiply it by itself. But if I do it to the bottom, I have to do it to the top. Remember in algebra where you multiply by the well-placed 1? So this is the same thing. I'm multiplying by 1 essentially, and then you just multiply straight across. square root, or 3 times square root of 2 is just 3 on the square root of 2. Square root of 2 times itself, remember the square root will always cancel out, and it just leaves me with 2. So now the radical is not in the denominator anymore, and I am super happy. Okay, let's look at this one. This one is kind of the same story over here. Square root of 2 divided by square root of 3. So nothing's going to simplify, so I don't have to do that step. All I have to say is, whoopsies, square root of 3 in the bottom. That's not allowed, so I'm going to multiply it by itself. If I do it to the bottom, I have to do it to the top. And then we multiply straight across. Well, that was unfortunate. This is not correct on my typed out notes. My bad. Square root of 2 times square root of 3 is square root of 6, which doesn't break down because that's just 2 times 3. It doesn't go anywhere. And then square root of 3 times square root of 3 is just 3. So your final answer should just be square root of 6 over 3. My bad. Okay, let's look at example 5. We're getting a little trickier here. So for example 5, square root of 5 doesn't simplify, so I just move them on over. Square root of 24, I want to break that down before I start multiplying, otherwise you have these huge numbers everywhere. So remember from up top, square root of 24 breaks down into 2 square roots of 6. Now the 2 is not my problem. I don't care about him. He can be on the bottom all day long. All my problem is the square root of 6. So multiply it by itself on top and bottom, and multiply across. Square root of 5 times square root of 6 is square root of 30. Square root of 6 times square root of 6 is just 6. But do not forget about this 2 right here. He has to tag along. So I have the 2 from over here times the 6 from multiplying my square roots, and that's where I get 12. Okay. Square root of 30 is 2 times 3 times 5, so that doesn't break down. I'm going to leave it just like that. Okay, again, square root of 3 divided by square root of 6. Square root of 6 doesn't break down, so I just multiply him by himself, top and bottom. 3 times 6 is 18. Square root of 6 times square root of 6 is just plain old 6. 18, remember, is 2 and 9. 9's the perfect square, so that breaks down to 3 square roots of 2. So what you have left, this is just a normal old fraction. Just because the square root of 2 is hanging on doesn't mean he's any different. So I need to simplify that fraction. 3 divided by 6 simplifies to 1 over 2. So I can just leave it like that. With the 1, without the 1, it doesn't matter. It's all the same thing. All right, you guys try these 3, and then I'll work them out, and we can come back and meet. So the first one's one of the easy ones, and then 2 of the more challenging ones. Okay, so the first one was nice and easy. Square root of 9 is 3. Square root of 25 is 5. So 3/5 is your final answer there. Number 2. So I simplify first. Square root of 36 is 6. And square root of 12 is 2 on the square root of 3. So remember, the 2 is not bothering me, only the square root of 3. So I multiply by itself, top and bottom, and multiply across. 6 times square root of 3 is 6 on the square root of 3. 2 times this becomes 3. So 2 times 3 is 6. Then I have 6 over 6, so that cancels out and just leaves me with the square root of 3. Over here, simplify first. So 24, square root of 24 breaks down into 2 square roots of 6. Square root of 8 breaks down into 2 square roots of 2. Can you see how being really good at breaking down square roots is going to make this problem go from forever long to more manageable? So the better you are at simplifying, the better you are at all of this. Okay, at this point, the 2's already cancel out, so I want to go ahead and simplify that. So then I just have square root of 6 over square root of 2. So I multiply by square root of 2, top and bottom. 6 times 2 is 12. Square root of 2 times square root of 2 is 2. Then I brought that down here because I ran out of room. So break down square root of 12 again. That's 2 on the square root of 3. The 2's cancel out, and again, just leaves me square root of